Hi, I am Professor Praveen Parmar, and this is an introductory session of business analytics. So let's we start this session. First, we understand the various subdomain of data science. Business analytics is also one of the domain of data science. So as you see here, the data science process. In the whole data science process, how does it work? We see first we collect the data. So there are various way to collect the data. One of them is through the questionnaire we could collect the data. That is a very simple process, everybody knows it. Another is sensor generating data. You know that the sensors in machines or somewhere else, it automatically generate the data through the sensor, and we collected data. Okay. Also through some software or the web application or the mobile application, we also collect the data. Okay. So there are various sources of collecting of data. Okay. And then the second stage of data science process is the cleaning of data. So whenever we get data, it does not mean that it is a clean data. Sometimes we have to clean the data. We have to fill the missing values. We have to remove the outliers or some other sort of things which are there in data. Data cleaning. In the data cleaning, there are various things we do in the data cleaning. Suppose we have a column where age of the people is mentioned, but along with that age they are also writing years. So it is basically a character or the string. So whenever we perform any calculation, it does not work. So what we do, we remove that years from that particular column. We just keep the numbers only. So that is one sort of cleaning process. There is various tasks in the cleaning. Okay, then we have exploratory data analysis. We explore the data. Okay, and we find out the relation between two variables or multiple variables, the effect of different variables on a particular variable, what is the effect. And then also we find out the univariate analysis of each variable. Okay, that is the first part of exploratory data analysis. We will discuss later about this sort of analysis. And after exploratory data analysis, we forward to model building, where the predictive analysis starts. Okay, then model deployment. We have to deploy that model in some software, some web applications. Yes. Now we see what is statistics, what is data analytics, what is business analytics, what is BI analytics, what is data science. So we want to understand these all things one by one, because in core of data science there is statistics and mathematics. So first we understand what is statistics basically. So statistics is a science and art of collecting, classifying, computing, analyzing, interpreting and presentation of data and its insights. Here you see it is a science and an art also. So through the statistics knowledge, we know how to collect data, where to collect data, from whom to collect data. Okay. Then we classify the data, whether it is categorical, it is ordinal, it is orderable, it is binary, it is interval scale or ratio scale, whatever. We classify the data. And then we compute the statistics. Whatever the statistics we require, we compute through this mean, mode, median, standard deviation, mean, absolute deviation, correlation analysis. This all we perform through the computation. Through the computation, we get some results in the text or the number format. And then through the analyzing process. Analysis is the thought process. Okay, we analyze that value, what does it mean, and then we interpret it. the complete meaning of that value, what does it indicating. So that we do through the interpreting it and presenting of data and its insights, the last task. So this is the role of statistics, because it is in the core, it is science and art. Now we try to understand why it is science. Okay, so here one small data set is given, and I want to know what would be the mean of this data. So if you calculate the mean of this data, if you are not performing any calculation mistake, so we all will get mean 8, which is correct. Okay, so we are all getting the same mean. What is the reason behind that? It doesn't mean that I am more experienced than you, my mean would be better than your mean. It doesn't mean that. So here it is a science, there is some method by which we calculate this. So somewhere we are using some method, so that is the science. So that's why statistics is a science. Okay, second thing, we see why it is an art. Suppose we have to interpret this glass of water. How do you interpret this glass of water? So some may say that it is half filled with water, some may say that it is half empty, but one experienced person who is experienced in analysis, he will reply in a different manner. Okay, he will reply like this: this glass is full, half with water and half with air. So this is the correct interpretation of this glass of water. So in this way it is an art, because art always require the experience or the practice. Okay, now we see the definition of data analysis. What is data analysis? Data analysis is a process. As we have seen, the statistics is a science and art. So data analysis is a process of inspecting the data. So there is a very big amount of data you could not inspect in one glimpse of data. So you have to inspect the data with the help of certain tool and certain statistics. Okay, you could inspect that data, you could understand the nature and behavior of the variables and these all things. So inspecting, the process of inspecting the data, cleansing the data, how to clean the data, this is the process. Transforming the data, you are aggregating something like you have a daily sales, minute to minute, and then you want day wise sales. So you will transform that event wise sale to the daily sale. So that is the transforming of the data. And modeling data with the goal of discovering useful information, whatever the information you can get out of the data, and informing conclusions and supporting decision making. So we have to find out the conclusion out of that information and which may support in decision making. Okay, this is the data analysis, which is a process of inspecting, cleansing, transforming and modeling data. Okay, now we see where does it focus. The data analyst focus encompasses a range of analytical techniques, including statistical analysis, data mining and machine learning, to uncover patterns and trends. Okay, so we use a wide range of analytics techniques, okay, including statistical analysis, as I explained you, and data mining and machine learning also, to uncover the pattern and trends. What are the patterns in the data we are getting, what are the trends the data is showing. So we focus on that. Okay, then what is the purpose? Generally focuses on extracting insights from data, whether for business, scientific or research purposes. So data analysts play a role in every field, without a specific emphasis on business strategy. Okay, so this is a clear cut, we can say that neutrally the data analyst find out the insights patterns or trends. What about the business analytics? Business analytics refers to the practice. As you have seen, statistics is a science and art, data analysis is a process, business analytics is a practice of using data analysis and statistical methods to gain insights and make informed decisions in a business context. Okay? It involves the exploration, interpretation, and visualization of data to uncover patterns, trends, and correlations that can help organizations optimize their operations, improve performance, and achieve their goals. So it is only with the business context we do the analysis. Okay. So the focus we see here, it focuses on the application of advanced statistical and quantitative methods to identify trends, patterns, and future business scenarios. And now, purpose. Its purpose to support strategic decision making, optimize process, and provide actionable insights from organizational success. Now, there is one more term, that is the business intelligence. Business intelligence involves the collection, analysis, and presentation of business information to facilitate decision making. Okay, we see where they focus. Primarily concerned with reporting historical data, generating dashboard, and providing a comprehensive view of key performance indicators, KPIs. Okay, and we see the purpose. The focus is on descriptive analytics, offering a retrospective view of business performance to aid in monitoring and reporting. So business intelligence generally required in a field of NGOs mostly do these sort of things. Okay. Now the last term, which is the data science. These are all whatever we have gone through up to now about data analyst, about the business analyst, about the BI analyst. They are all the subdomain of data science. So data science is an umbrella term that encompasses data analytics, data mining, machine learning, several other related disciplines. Data science is an interdisciplinary field that uses scientific methods, processes, algorithms, and systems to extract knowledge and insights from many structural and unstructured data. Data science is related to data mining, machine learning, and big data. So it's a big umbrella under which this all domain works. Finally, business analytics combines elements from computer science, mathematics, statistics, domain knowledge, and data engineering to analyze and interpret complex data sets. Okay. Business analytics is the systematic use of data, statistical analysis, and quantitative methods to drive informed business decision making. It involves the exploration, interpretation, and communication of meaningful patterns and trends within data sets. So this is basically the work of business analyst. Okay. Now, as you know that business analyst is a sub domain of data analyst. Okay. So we see what is data. There are two words, data and analytics. Data analysis. So first we understand data, then we understand the analysis. So here I would like to define what is data. Data refers to raw facts, statistics, or pieces of information collected or stored for reference or analysis. It can be in various forms such as number, text, images, audio, or video. Essentially, data is the foundation of all information, and it becomes meaningful when it is processed. Okay, analyzed and interpreted to drive insights or make decisions. Data can be structured, semi-structured, or unstructured depending on how it's organized and formatted. It's critical asset in today's digital age, driving advancement in technology, business, science, and various other fields. So this is the basically we can understand about data. What is data? And now we see what is the classification of data in context of data or business analyst. Okay, so I am here talking about the structured data only. Okay, so structured data we have divided in two parts. Number one is categorical data, number two is numeric data. If I talk about the categorical data, again we have divided this in two parts. One is nominal data, second one is orderable data. So we will try to understand what is nominal data, what is orderable data later. After completing this slide, I will explain you that. And numeric data we have divided in four parts. Number one is binary data, second is ordinal data, third one is interval data, fourth one is ratio data. Interval and ratio both are scale, and we say it is a scale. And again we have divided this in two parts, that is discrete and continuous data. So this is the hybrid classification of data which we use generally in the data and business analytics domain. Now I would like to explain you about this categorical data, what is nominal data, what is orderable data, what is binary, ordinal, interval, ratio, scale, discrete and continuous. So we see this on our whiteboard. Categorical data. In the categorical data we have first one is nominal data. In the nominal data I take one example of gender. In gender we have three categories. Suppose we have male, female and transgender. Okay, I will explain it later. Now I want to tell you now I will explain you first about the orderable data. Then after that you can better understand the nominal data. So we write here orderable data here. In orderable data I take the example of education. Okay, in education I take the different categories: illiterate, primary, I am randomly writing these levels now: PhD, graduate, middle, postgraduate, high school, and inter school. So we see how many categories are here. So as you see, 1, 2, 3, 4, 5, 6, 7, 8. Now I ask you to give the order from lowest to the higher education. So I think that the person who is literate, having some knowledge, will give the same order. Here I give the order. Suppose if somebody is giving the order like illiterate 1, primary 2, everybody will give the same order. Middle 3, high school 4, inter 5, graduate 6, postgraduate 7, and PhD 9. 8. So the same order, everybody will give the same order. So we can give order to these categories. It is a orderable. But if I ask you to order this gender, male, female, or transgender, so everybody will give the different order. Somebody will give male 1, 2, 3. Some give in this manner. Some give in this manner. So there may be there is not possibility of the uniform or the same order. Okay, but in education level everybody will give the same order. So there are two types of categorical data. One is the nominal, other is the orderable. Okay, so this we understand. So what happens when we give order to this sort of categorical data? So that order we use only this numeric value, that is called the ordinal data. That is called ordinal data. Okay, that is called ordinal data. So I again come to my slide and I explain you some other things. So nominal I explained you, orderable I explained you. Now ordinal I have also explained you. When we use the numeric value of orderable data, that is called the ordinal data. Binary is in the form of 0 and 1 only. Interval ratio is the data like age, income, distance. These are all interval data or the ratio data. So there is a difference between interval ratio data. We will see later about this. And these two are scale, other are data. Ordinal is not a scale. Okay, it is a data. Binary is a data. And so interval and ratio only scale, and this again we classify in two part, discrete and continuous. So I will explain later about this, about the discrete and continuous. Okay, now we see the classification of analysis. Analysis refers to breaking a whole into its separate components for individual examination. Analysis means to do the post-mortem. Okay, and data analysis is a process for obtaining raw data and converting it into information useful for decision making by users. Okay, data is collected and analyzed to answer questions, this hypothesis or disparate theories. So here I will explain you the classification of analysis. As you see, we have classified this analysis in 4 parts. Number 1 is descriptive. In the descriptive, second one is inferential or diagnostic. Third one is predictive. Fourth one is prescriptive. And predictive, if you see the descriptive, it means whatever thing in your data. How many males are there, how many females are there in some conference like that. So that is the descriptive analysis. Their average in an organizations, the average income of male and average income of female, whatever the statistics, mean, mode, median, standard deviation, range, coefficients, and these all is the descriptive analysis. Inferential analysis, why it is? It is the study of cause and effects. So we diagnostic why it happens. So that is why it is. Third one is predictive. Predictive is what will be. Okay, it will predict if you have a data of rain of last 10 years, 20 years, and the data of crop also of that region. So you could easily predict as per the rain what would be the crop production this year, amount of rain. So that is a predictive analysis. And this predictive analysis is basically the machine learning starts from here. Okay. Fourth one is our prescriptive analysis. What should be? Suppose we have, it doesn't mean that only rain affects the crop production. There are many other factors which affect the crop production. like the soil quality, seed quality, pesticides, fertilizers, sunlight, humidity, irrigation. So these all also affects the crop production. And if we use one artificial intelligence model, we develop one artificial intelligence model, so we could ask them, suppose your predictive model predict that you have input all the values like the soil quality, nitrogen, phosphorus and potassium content, seed quality also, sunlight intensity also average, humidity also you have fed over there, what fertilizer you will use there, what pesticides at what time you will use, and the irrigation also you have put these all values, and your machine learning model predicts you will get 100 metric ton of the crop, but you require 140 metric ton. Then what you will do? At that moment we have two options. Either we could take the expert advice. Okay, expert may be of two kinds. There may be human expert, there may be artificial expert. Human expert means human intelligence. You could ask through the experienced farmer. You can ask through the to the agriculture scientist. Okay, so they will suggest you, your soil quality is this, so you will use this particular fertilizer. Okay, this particular seed you have to use. So after getting his advice, you can increase your crop production from 100 metric ton to 120, 130, 140, whatever. Same thing, if you have a artificial intelligence model already developed, you could ask to that model, we have this thing, rain is this much, sunlight is this, which is not in our control, so what seed should I use for getting the crop production by 140 metric ton. So that artificial intelligence model can prescribe you, can recommend you what pesticides you have to use, what fertilizer you have to, what seed you have to use. Okay, so if you follow those recommendations, your crop production may increase from 100 metric ton to 140 metric ton, may be possible. So here it is called the artificial intelligence. So this was the classification of analysis. Now I will show you the various types of analysis, how we get it. So here you see we have a movies data, and we have the age of gender of the audience, location, age, and past movies, Netflix or something like that. Okay, so we have these all information. So what analysis we can do, what sort of analysis it is being called, so I will explain you later. Now we have another data about the sales of particular shampoo, the factor responsible for sales reduction. So what sort of this analysis? Third one is viewing websites today's traffic. Okay, so this is another data we are getting, and predicting stock price movement. So this is another. So we see what are the what analysis we can perform of these four type of data. Okay, so you see about the descriptive analysis. So this one, today's traffic, we are viewing the website today's traffic. It is a descriptive analysis, the current situation, whatever we have. So it is the today's traffic, no past data required, no future outcome required. Okay, second we see the diagnostic analysis. So here the factor responsible for sales reduction. What are the factors? Which factors are affecting our sales in positive manner or the negative manner? So analyzing past data, no future outcome or forecast here again. And predictive analysis. Predictive analysis, you will see here the predicting stock price movement, analyzing past stock prices, analyzing similar stocks. Okay, and finally future stock price required. Okay, so this we can predict. That is the predictive analysis. Fourth one is the prescriptive analysis. Here you see about the movies data. Let's start with recommending moves. movies. So you will see the gender, location, age, past movies. These all informations we have. So the past, the person has watched the horror movies. The future unwatched horror movies. This may be, but you see the similar people, the demographic of the people are same. So the similar people watch the classic movies. So suggestion for you, maybe the Godfather. So this sort of the recommendation engines works in this way. So it is the prescriptive analysis, artificial intelligence. Thanks.